Here's a great view of the remarkable architecture of Model S. The front of the car is truly state-of-the-art. We have a space frame or open architecture here featuring a combination of castings and extrusions with a few stampings. Here we see the cast suspension turret members, which are extraordinarily well shaped and very functional, very stiff, lightweight and great in crash. And across them we have this very large cross member, which we are able to put in place because we don't have to clear a conventional gasoline engine. And all this is triangulated with this cross brace, this diagonal, creating a series of triangles well known to optimize stiffness. Stiffness is vitally important in a car, not just for ride and handling, but for making sure that the body has that vault-like feel, that lack of shake, which is synonymous with a real quality product. Safety is a recurrent theme on this vehicle. Here we see a very advanced crumple zone. These deep extrusions, these aluminum extrusions, which are perfectly straight, unhindered by the intrusion of a conventional powertrain. Again, we see this characteristic double octagon section, which is such a good shape for absorbing crash energy, ensuring that the G-forces in an impact are reduced, therefore less injurious to the occupants. Well, here we see a really great view of the cooling system for the Model S and the radiators. And it may be surprising to some that it's necessary to have radiators and cooling on an electric car. But it's very necessary and very much part of the advanced powertrain monitoring system that Tesla has developed. In order to extract the very best out of the batteries, it's imperative to keep them at a uniform temperature and to control that temperature in a computer-controlled way. And here we see a heat exchanger, a central heat exchanger for that function. And either side we also see condensers, and these are for the air conditioning systems within the car to keep the cabin at an acceptable temperature. But overall, we have far fewer radiators and less area of radiator here than in a conventional vehicle. And that in itself is important for efficiency, for aerodynamics and range. And also, we see that the entire system, together with this ultra-high strength steel boron bumper system, which in itself is a state-of-the-art feature, is combined with this aluminum intensive carrier in a module. And that modularity will allow us to build Model S at 20,000 units a year in a repeatable fashion. You see, quality is not just a function of how things are assembled on the production line, but I passionately believe that quality is designed in from the outset. We've engineered Model S to be a great driver's car. Great in terms of ride and handling, those indefinable attributes that distinguish a great driving experience from the mediocre. And a crucial part of that is this rear suspension, this multi-link aluminum intensive rear suspension that has been designed specifically for Model S, designed in-house by Tesla's vehicle suspension design team and been optimized for this particular vehicle with its particularly low center of gravity and great dynamic characteristics. And let me take you through some of the details here. We see this imposing large diameter rear disc rotor. It's larger than one would normally expect for a rear axle system. And that's because we have a very low center of gravity for Model S, and we expect the rear brakes to contribute more so than in a conventional vehicle. So looking a little bit behind here, we see the suspension links themselves. These are unique to Model S. They're made from extruded form of aluminum. And these are exceptionally light and exceptionally rigid, both vital attributes for a great suspension system. A centerpiece of Model S is this advanced aluminum structure, the body shell of the vehicle, which embodies the car with great safety performance because it comprises the safety cage which protects the occupants in a crash. We're particularly pleased with this. It's a very advanced form of architecture which uses a combination of castings, extrusions and stampings. And here we see in the rear arch the stamped wheel arch inner panel and capped with the cast upper. We have another significant casting which runs through the lower part of the structure, this underbody here, which we call the rear torque box. And this is a semi-permanent mould casting. And look at the shape of this, how it blends and flows. It's very organic in its form, and that adds to the stiffness and performance of the car, and moreover it reduces the weight. Now, package is a very important aspect of Model S. What do I mean by package? It's the efficient use of space in the design of an automobile. And Model S has such extraordinary package efficiency, it's possible to endow it with a third row of occupants. And the third row sits effectively here on this panel. And underneath the panel is a very compact electric motor, drivetrain, power electronics and gearbox, and of course the multi-link rear suspension system. So here we are underneath the Model S, and I think this is really the key to what makes it so great. We see this extraordinary flat expanse of battery pack which covers the entire underbody of the car, bringing the centre of gravity down and providing the perfect aerodynamic form for efficiency as it cleaves through the air. The battery pack sits neatly underneath the floor of the vehicle, optimising package space. The battery pack is also extraordinary because it augments the structure. Let me tell you that this unit in itself has the torsional rigidity of many conventional sports cars. But when it combines with the body structure of Model S, it doesn't just add its own torsional rigidity, it adds nearly 3 times. And that's through the technology that we developed in the way that the marriage of battery pack to body structure occurs. For us at Tesla, the use of three-dimensional space and packaging space is an obsession. It is our mission to optimize the shape and space of every piece of the car. This is exemplified by this extraordinary package that we see here. This is the rear subframe, which carries the advanced multi-link Tesla rear suspension system. And deep inside that module is the Tesla electric motor, gearbox, and not only that, but we have incorporated the power electronic inverter module as part of this package. And this is a great innovation to position the power electronics so efficiently right next to the motor, and to package that, to shrink wrap that with the subframe and the suspension has been quite an achievement. And that's been achieved through very close collaborative working between powertrain teams, between suspension, chassis and the body engineering team that's had to accommodate all this. And that is a great outcome of the advanced engineering methodology that we employ at Tesla, which is a real differentiator. We have a very lean team. We have people from different disciplines sitting right next to each other and sharing the collective experience of designing and packaging the car.